Thank you so much, everyone, for joining us today on our webinar, Reduce Your Java AWS Infrastructure Costs by 1,000 times, 100 times or more, brought to you by Geniusee. My name is 𝘁𝗶𝗵𝗲𝗀, and I'm a Partner Development Manager at AWS. Today, we're going to deep dive into strategies and techniques that can help you dramatically reduce your Java AWS infrastructure costs. Just before I begin, I want to highlight our Q&A box. You'll see a chat box, but you'll also see a Q&A box at the bottom of your Zoom screen. We'll wrap up today's session with an interactive Q&A segment. So throughout the presentation, please drop your questions in the Q&A box, and we'll revisit those questions at the end of the presentation. So let's meet today's speakers. So representing on the AWS side, we have Bhavye Sharma. He is a partner solutions architect here at AWS. He has over 5 years of experience, really works closely with our partners here at AWS, kind of our technical know-how within our partner support team. And we have Andrii, Malyna. He is the Java lead at Geniusee. He has over 7 years of experience, super enthusiastic about sharing his advanced techniques today around using Java frameworks to achieve impactful business outcomes. And I'll let Bhavye kick us off here to introduce today's agenda.
All right. Thank you, Abby, for the introduction. And thanks to the Geniusee team for setting up this webinar. So today, Andrii and I will be discussing how using Quarkus-based Java applications combined with the compute services offered by AWS can help you accelerate your workloads while exponentially saving on costs. And I know Abby mentioned 1,000 times by accident, but depending on where you're coming from, that might be possible as well. And we'll look into that when we go into the case studies. Throughout today's discussion, we'll be looking at 3 main metrics. That will be latency, throughput, and costs. And these are the dimensions we'll be exploring while we play around with this technology and what AWS has to offer. And Andrii will be taking over and explaining a couple customer case studies that Geniusee has successfully implemented and shared their expertise on using Quarkus for migrating Java workloads. Next slide, thank you. So the first and most common option that we see for deploying Java applications in the cloud is using EC2 instances. EC2 stands for Elastic Cloud Compute. It's offered by AWS. Java as a language has been around for many years. And if you look at the history of Java, it was originally developed to be used on on-premise environments. So if you have that's sort of similar to what EC2 has to offer. Like you get full control over a server instance, and you can do what you want with it, similar to how you would have on an on-prem environment. When should you use EC2? So if you're going to have an application that needs to be running 24/7, 365, and is constantly getting over 10,000 requests per second, then that's when you should be exploring EC2. And the reason for that is that EC2 has this feature called reserve instances that can help you significantly reduce costs. So for those who are unaware, reserved instances are a purchasing option offered by AWS that requires you, the end customer, to commit to a specific instance, a OS, and a tenancy model, and for a period of 1 or 3 years. You can tell us that, hey, we're going to be using this EC2 instance for the next 3 years. And what AWS can do is offer you savings of up to 70% on those EC2 instances. So if you have some legacy on-prem Java applications that you want to move to the cloud, then this is one of the options. But please note that you still have to do a lot of operational overhead tasks. So this could include security, patching, and other operational activities. So this, we call it in the AWS world as a lift and shift migration. And this by itself is usually not sufficient to unlock the full potential of the cloud. Next slide. Oh yeah, so Andrii will take over and explain this architecture diagram.
Yeah, thank you, guys. First of all, we prepared architecture diagram for our first example. It is basic architecture diagram for typical system where we have EC2 instances located in the autoscaling group, and there is also a connection to our Postgres database. It is worth noting that inside this EC2 instance, we have a container with a small microservice that performs basic CRUD operations to simulate a real environment. The project is written using Java 21 and the latest version of Spring Framework and Spring Boot. About, first of all, load and performance limits, which we received. On this slide, you can see the results of the load testing in the client launch. We choose this option to avoid statistics error related to the network, and you will find all results in this tool. The load was generated using the tool, namely WRK, and Lua scripts that emulate the CRUD activity of users. The load configuration is identical for all services which we use for this webinar. You can also see the resources which we use for these services, EC2 to micro and RDS. For such a resource, the response time was about maximum response time was about 540 milliseconds. The proceed number of requests was slightly more than 30,000 requests per minute. We didn't have any errors during the processing of requests. It worth noting that these metrics are quite good for this type of resources, but we must remember that under the hood we have a very simple service without complex logic. In case if we will use some real project and with more complex service, the values will be a bit worse. Sorry. What about costs? For such configuration, we can find more information by scanning our QR code. You will find the configuration of EC2 with all numbers and etc. As for the bills, here we can see that for one microservice, just for one, this configuration will cost $157 per year. We don't take into account the price of the database and etc., but just for EC2 instance. Okay.
All right. So, I touched upon this a little bit, but let's discuss when and why you shouldn't use an EC2 instance for your Java application. Well, first of all, if you're not sure how much traffic you're going to be getting or expecting, maybe you just expect a couple hundred API requests a minute, then EC2 is probably not the right choice, since you'll be paying for renting that server regardless of how much of it do you use. Like, regardless of how much load is on it, you will be paying a fixed amount of money. Similarly, if your legacy Java application is not using a framework like Quarkus, which is cloud native, and you still want to leverage like a microservice architecture, then EC2 is not the right choice, just because of how bloated and how much of a large memory footprint legacy frameworks have. So you won't be able to host a whole bunch of microservices in a single EC2 instance, because like the heap and the amount of memory footprint that each of your microservice will have won't let you provision more than a couple of microservices. If you want to have hundreds of microservices in an EC2, that won't be possible, and you'll be just throttling and not being able to run your application. Similarly, I already touched, we also touched about how there is a lot of operational overhead with EC2 instances. Like, you will be responsible for patching it, for all the security updates, and so on. So that's another task that you'll have to worry about, which is something that other compute ops services that we'll discuss later will take care for you. Yeah, next slide. All right, so next is ECS, or the Elastic Container Service. So ECS can streamline deployment, and as you may know, and if you already have experience with containers, it can really simplify the deployment process of containers. Another benefit of using containers is that it reduces the threat vector to your applications. So you may know that containers are inherently immutable and therefore more secure than just running an application directly on the host. This month, I'm sure you guys must have heard, there are so many new vulnerabilities coming out. I think this is the month of vulnerabilities, like be it SSH or PHP GNU library, all of them are getting more and more vulnerabilities, and it's getting an increasingly important concern for AWS and all its customers. So we'd definitely recommend that you should containerize your application regardless of which compute service you use. Another benefit of using ECS with containers, you have to use containers, is that it allows you to seamlessly scale horizontally. So as your load increases, ECS can automatically and quickly spin up new container instances to handle that load, and AWS will handle the provisioning and scaling of resources, allowing you, the customer, to focus on developing unique products that you can share with your customers. And the final benefit is that ECS supports EC2, so you can leverage that benefit of reserve instances that I talked about, and you can also use Lambda, which we'll dive deeper in the coming slides. Yeah, sorry, go ahead.
Yeah, thank you. Conceptually, we have a very similar architecture for our second example. Here we have ECS instances located in the cluster and connected to the database. The project which we have inside this ECS instances is similar for the first example. It's the same project. So go deep to the details. Load and performance. ECS showed a bit better result for the same load configuration. The maximum response time was 352 milliseconds, and the processed number of requests per minute reached almost 44,000. The results are quite good, but we also have to remember that we have a fairly simple microservice without complex logic. So for more complex system, the values will be worse. But this result also quite good. Costs. As I mentioned for the first example, if you want to see details, just scan QR code and you can find all configurations. And just for in our cost, we calculate just service which run our Java application. For this example, the price of such solution will be amount $170 per year, just for one microservice.
All right. So talking about the cons or when you should not be using ECS. So first of all, I'm nitpicking here. There are a lot of benefits of using ECS, but if I were to talk about a few, one of them is that if you decide to go with ECS, you are sort of restricted in a multi-cloud setting. Since ECS is a feature of AWS, so as long as you're inside AWS, you'll have a great experience and you won't have to worry about patching or scaling and so on. But if you want to have a multi-cloud deployment with multiple different cloud providers, then this might be a limitation for you. Another reason for you to use something like Kubernetes or EKS is if you're already, proficient in it. If you have developers that are certified in using EKS, you wouldn't want them to go and start learning another orchestration platform, which can have a steep learning curve. And finally, if you have workloads that are going to be idle for long times, as I said, serverless will be the right choice for you. And if you want to, learn more about why, why it's important to have these containerized Java applications, there's a great talk by 𝘁𝗶𝗃𝗀. She's one of the maintainers of Quarkus, which talks about why, you can't have microservices without containers. Yeah. All right, moving to the fun stuff that everyone's here for. So Lambda plus RDS, when and why you should use it. So Lambda lets you scale down to 0. That is, if no one is using your app or calling your APIs, then you basically won't have to pay anything. So you only pay for what you use. And we at AWS believe that the biggest selling point for you to move to the cloud is so that you don't have to worry about operational tasks, and you can focus on building unique, innovative solutions, and let us worry about infrastructure, which is exactly what Lambda offers. Finally, Quarkus has this, Quarkus doesn't really, if we compare Quarkus to Spring Boot, Quarkus does a lot of, the computation at the build time. And what benefit that offers you is that when you actually try to run your app, it's almost instant. So, if you compare it to something like Spring Boot, when you run a Spring Boot application, it has to do a lot of stuff. It has to do class path scanning. There's a long time before the thread pool starts. But if you use Quarkus, a lot of that computation is done in the early stages, known as early binding. And you don't when you try to run the app, it's almost instantly. And the trade-off there is that you have a longer compile time, but your runtime is lightning fast.
Yeah, thank you, Bhavye. Totally agree with you about funny stuff. Finally, we can discuss the last example, the option of working with Lambda. As you can see here, instead of server solution, we use serverless. There is a CRUD microservice similar for the previous example, but that work with Quarkus inside this Lambda. In this case, we do not have a server that works 24/7. This gives us an advantage that we pay for the resource only if we use it. Previously, this solution was rather inaccessible to us, but now, with help of Quarkus, it has become possible. Let's talk about details. Let's evaluate the possibility of handling the load and scaling. It is worth noting that in this example, the smallest possible variant of the Lambda configuration was used. It is 128 megabytes of RAM, which give us a bigger virtual processor compared to the biggest part of memory. With the same load tool settings as for the previous services, we got a value of 147,000 requests per minute with 243 concurrent executions of Lambda. That is, we didn't approach the maximum values with the standard configuration. Amazon allows 1,000 concurrent execution, but this value can be raised simply by contact AWS support, and they will increase this number. At the same time, a big problem, and the reason why the solution was usually avoided was the cold start. But now it has changed. Here we can see that all the cold starts, which is 243 requests out of more than 200,000. The maximum duration was a bit more than 1.5 seconds. All the other cold starts cases less than this value, and it's totally cool. At the same point, the average duration was only almost 50 milliseconds. And let me remind you that you pay for the time of use. And this is great combination for us. Let's go to the costs. Okay. In this case, if we will use Lambda, one microservice will cost approximately $7 per year. Provided that the load on it will be up to 2 million requests every month without taking into account the free tier. If we take into account the free tier, then this price is for 3 million requests every month. As I mentioned before, you can find information by scanning the QR code and find all configurations. I also want to remind you that we will also analyze a real case of migration and cost effects.
All right. So talking a bit about why Lambda might not be the right choice. So first of all, there's some restrictions as to what kind of compute you can power for your app, can power your application. So if you have something that requires a GPU, for example, if your application needs a GPU and needs to do that inference, for example, like a AI inference, not inference, training. Inferences can be done on CPU. But then Lambda is not the right choice for you because currently Lambda does not have the ability to attach a GPU to your endpoints. Similarly, there is a concurrency limitation of 1,000 executions, but this, of course, can be modified. You can raise a request to AWS, and we can increase that to however much amount you want. One hard limitation of Lambda is in Lambda layers. So for those who aren't aware, Lambda layers is a feature of our Lambda functions that lets you preload some dependencies and libraries, but there's a restriction that you can only have up to 512 MB of those dependencies preloaded. So if you want to do more than that, there is the option of containerizing your whole Lambda function. It is a little more effort and a little more overhead, but that is one limitation to be aware about. Another hard limitation for Lambda, which cannot be modified, is the execution time limit. So when you make an API call to a Lambda function, if that API call takes more than 15 minutes to execute, your execution will fail and you will not get the response back. So you have to be sure that whatever code you write, that can get completed within the 15-minute time period. There are some ways around it. You can use something like an SQ to process it and respond to it later, but it's more effort, more complications. So you should be aware of that. Finally, cold start used to be a problem. We had done at AWS had done a lot of work, using snap start and other things to optimize Java, but it's nothing compares to just simply using Quarkus with something like Graal VM that can compile your Java application to native binary code that runs super fast and responds even faster. All right, so now I'm going to ask Andrii to talk about his case studies. Geniusee is an advanced tier AWS partner, and they've done a lot of work, helping customers migrate to Quarkus and migrate their Java workloads. So yeah, take it away, Andrii.
A bit no. First of all, I would like to compare our example side by side. First of all, let's review the performance comparison for our test project. The average request processing time for EC2 was slightly more than 400 milliseconds. For ECS, it was almost 200 milliseconds, while for Lambda, this number is less than 50 milliseconds. We can see the difference between the amount of load that the service can handle with such resource. And we have to remember that we have now reached its limitation for Lambda. So this statistics is requests per second, and Lambda can handle much more. But if we're talking about the price for just one microservice, the results speak for themselves. I think the serverless option is the most profitable. But let's discuss real world case. Let's consider an example of a real project where the client approached us with a certain problem. Let's talk about architecture. Here we have classic server-based architecture where we have a group of microservices that work in ECS. Instances communication between services is based on the event-based architecture with communication through Kafka. Also, this client used for some tasks ready. It's not a big deal for this example, but just for mention, communication was made with communication with database was made by Spring Data. For our Quarkus migration, it was not also a big critical. We just stay it's there. RDS was used Aurora serverless first version. We also stay on the same version. For our migration, it was not also critical. Number before refactorings and a bit information about client problem. Before the refactoring, the client facing the problem of unstable load. The number of requests per minute could change from 200 to almost 5K requests per minute, which caused problem because ECS and Spring inside the ECS didn't have time to scale horizontally because the load arose suddenly, and container with Spring had not much time to start up because Spring had an average startup time about 1 minute, and it created a problem when service unavailable for some users. The response time ranged from 500 milliseconds to 3.5 seconds, and the cost of all of this configuration was more than $50K per year, which was more than 30% of the total costs of the infrastructure, and the client decided not to increase numbers of instances which run 24/7. Just try to find another way how he can handle this load, and maybe some cheapest way to handle this load. After refactoring, first of all, let's talk about scaling. On this slide, you can see the result of this refactoring. As a certain moment, the load increased rapidly, but at the same time, the success rate is still 100%. We can also see the peaks of cold start that took a little more than 1 second, which is pretty good because when user send request to cold start Lambda, as usually he don't see any difference between cold start and hot Lambda. Such insignificant cold start time is merit of the combination of Quarkus and Lambda, which use a configuration of 512 megabytes of RAM, and as I mentioned before, in this case, it's better virtual processor. Let's go in more details. Here we can see this process of load growth. As usually, peak of requests was maybe 200 requests per minute, but after some time, after some after some business tasks, this load significantly increased, and we can see peaks on this slide where max load was a bit more than 4,000 requests per minute. It's not a big deal for Lambda, but for that project, for previous implementation, it was a critical. Result performance with Lambda 512 megabytes of RAM. It's crazy numbers because average duration was 13 milliseconds. It's totally cool results compare what we have had before, because for previous implementation it was 500 milliseconds to 3.5 milliseconds, and in this case it works much faster, and this client pay less for his infrastructure. But maximum duration was 1 second and a bit over. And this is a cases of cold start. But as I mentioned before, in this case with such number, it's not a big deal at all. What we had in the result. After factoring, the problem with unpredicted load was solved by changing this infrastructure part, and Lambda save us in this case. The response time to the request was an average of 50 milliseconds using the Lambda resources with 128 megabytes of RAM. We decided to use this amount of memory from financial point. The cost of all Lambdas was less than $50 per year. It is the price without free tier, and it is less than 1% of total cost of infrastructure. Savings compared to the ECS more than 1,100 times. This is crazy numbers, and the client was totally successful with such infrastructure. I think that's all from our part. Let's go to the Q&A session.
Awesome. Thank you so much, Andrii. So yeah, we have a couple of questions. I'll just go in order here. So starting off, how stable is Quarkus?
I think there's one in the chat as well. There's a question in the chat. I think that was before this one.
Oh, so. Okay. Let me see here. Oh, all right. So this one's to Andrii. Bhavye, obviously step in if you can here. In the case study, was there any improvement in developer productivity with Quarkus? Productivity also impacts cost.
Okay, as I mentioned before, we keep Spring data. We didn't migrate to some other solutions. It's save clients some time for this refactoring process because it's development time. We made some configuration changes for Quarkus, for Lambda, try to figure out the best configurations of each parameters, like memory, etc., where we can receive the best comparison between price and results. If we're talking just about code part, we made some improvements for AWS part, controller layer, and I think it was the biggest part. We didn't change some service layer in detailed, so something like that.
Yeah, I'd like to jump in. So Andrii answered it pretty well when talking about migrating an existing Spring application to Quarkus. Quarkus has these extensions that you can just implement, and your existing application will become a Quarkus application with not a lot of effort. As Andrii specified, you don't have to change all the MVC layers and all that, just a couple of layers. But when we're talking about like just developer productivity from scratch, let's say you're building an application, I think there are two main benefits that Quarkus offers that other applications don't. First of all, like, if you've been developing Java applications for a long time, we all know that Java Spring can be a very verbose language. Like you have to type a lot of Java code to get stuff to work. Yeah, there is a little bit of aspect-oriented programming. You can use some annotations and all, but still it is not as, if you compare it to something like Python, of course, there is no comparison to how much code you have to write in a Java application. And that's where Quarkus helps. Quarkus really, it really leans into using configured extensions that just build in functionality. Like if you try to enable logging in a Quarkus application, it'll be as simple as just enabling a logger rather than doing 10 things that other frameworks might do. Another piece of developer productivity is how quickly can you see your changes live. So, I've been like, if I were to build like a Spring application using JVM and OpenJDK, I'll like every time I make a change, I'll have to compile it, which takes a certain amount of time. I'll have to run it, which takes another bit of time. And that's just that's like a minute of my time just waiting for my code, just for me to see what changes I've made. But if you use Quarkus with OpenJDK or JVM, within seconds, like I'll save my file and it has hot reloading, or like I save my file and I can see on my screen my new application running as it is. So that developer feedback loop gets cut down greatly, and that can increase productivity as well.
Awesome. Thank you both. All right. So next question, does Quarkus fit for Kubernetes?
Yes, totally. It's not a big deal. Quarkus can run application in container and in the Lambda. As usually, when you start to build Quarkus application, it's totally similar like for Spring with Spring Boot. You will receive an image which you can run in the Docker, and it's totally fit for Kubernetes. If you would like to migrate it to Lambda, for example, you should add one dependency, a bit change your properties, add some configurations for the Lambda, and that's all. You just press build and receive a zip file which you can run in the Lambda. But if we're talking just a bit about Quarkus, it is also a great option because with Quarkus we can talk about native build. And if we compare it with Spring, as usual, for some small project, you should allocate maybe half of gigabyte of RAM, just to be sure that in some peaks of load, this small project will not generate some issues, exception, and etc. If we're talking about native build with Quarkus, this number of memory will be much less, maybe 50 megabytes of RAM. And just to image that you can run much more instance in the same with the same resources, and it can help you with handle of loads. Or another option, you can just decrease the number of resources which you allocated and use Quarkus and save your costs, to save your money with less costs.
Yeah, I'd like to add something as well. That was like perfect answer. I think it covered everything. But I would just say, like, when you say is it fit for Kubernetes, like I hear that question, is it fit for the cloud? Because Kubernetes is what the cloud is these days. And what does that mean? Like basically applications in the cloud or containers in the cloud, they need to be able to, they get turned off and turned off very frequently. Like they start and stop. You don't compare to on-prem where you have a server running all the time and you don't care how much it costs because you've already paid for it. In the cloud, you pay for every second of use. And what Quarkus lets you do is, like, when you spin up a Quarkus instance, it's, there's a study out there which says that it's turning on a Quarkus pod is faster than turning on a light bulb. So you don't pay for that loading time of, okay, my pod is starting, it's about to get in a running state. Your pod is up and ready when your request comes in, and it gets destroyed as soon as your request is completed. So that's how the cost saving piece also comes into it. And I think it's perfect. It's built for EKS or Kubernetes.
Totally agree.
Awesome. Thank you both. You talked about refactoring in that case study you presented. How long did the refactoring take in that case study?
As far as I remember, it was maybe half a year. Not bad. No, not much more time, because as I mentioned before, a big part of project we just reused. We replaced controller layer. we add configurations, a few configurations, a bit moment changes, but it was for 50 microservices, I think. Honestly, unfortunately, I don't remember correct numbers of microservices, but it not was few of them. And for such numbers of microservices, we just migrated for half of the year. But this time can depend from complexity of this of the project, because, for example, for some small project with where we have few microservices or even one microservices, it will be much faster. If we're talking about big system where we have hundreds of microservices or something like that, yeah, we should spend some time for that, but the result we will have much better, because as usually from my experience, if we have such number of microservices where we have hundreds of microservices, price of that is pretty big. And as you can see from our examples and our real case, real project, cost savings can be huge.
Thanks so much. Next question, is Quarkus a service agnostic solution?
Yes, as I mentioned before, you can run where you want. It can be EC2, it can be ECS, Lambda, EKS, Kubernetes, it doesn't matter. It's totally flexible. You just, as usually, you can receive container and run in the server-based architecture. If you decide to migrate to the serverless, you just need to add dependency and few lines of configuration, and that's all. It's totally flexible.
Yeah, I'd like to add, Java was created as write once, run anywhere. That was the point of Java, and I think Quarkus preserves that. There's no added functionality that makes it not possible to run your Java Quarkus application everywhere. So yeah, I agree with Andrii. It is a completely agnostic, based regardless of where you want to run it.
Awesome. We have one more question. If anyone else wants to add additional questions to that Q&A box, you can find it at the bottom of the presentation screen. But last question, Bhavye and Andrii, does development on Quarkus take longer than development on Spring?
It depends which version of Spring we're trying to compare. If we're talking about Spring 4 or 5, Quarkus will be much faster. I can provide some example. For example, for Auth layer, if as far as I remember, when we made integration with Cognito, unfortunately, I don't remember a version of Spring which we used for that project, but all business logic and integration was more than 1,000 lines of code. So it's pretty big scope and pretty big time for development. If we're talking about Quarkus, it will be 50 or 60 lines of all codes. I mean, dependency, configurations, and other part of code. So it will be much less code, and so it will be much faster. Also, if we will compare to the latest version of Spring, I think it will be similar or a bit faster if a developer will be familiar with Quarkus, because Quarkus has such tool like DevTool, and in case if we want to start our application in local environment, if we want to run tests, and etc., for our previous implementation, when we use Spring, as usually people use test containers or Docker with some additional services like database and etc. Where should you run this Docker container and run all this dependent services? With Quarkus, you can forget about that. Quarkus will take cover it by themselves, and it's total flexible option when you can replace our server locally, database, and etc. etc. So you can't worry, don't worry about that, and it will speed up your development process locally, and in result in total time of development.
Yeah, this time I'd like to slightly disagree with Andrii on some points. Spring Boot or Spring Framework has been around for a long time. You'll find a lot more developers who are familiar with Spring. You will find a lot more blogs or tutorials. So it might be easier for you to develop. Okay, you might have to write more lines of code. You can copy that, and these days AI can write code for you. But the benefit of using Quarkus is performance. So if you have to worry, like think about what matters more to you. Is it high throughput, high low latency, or do you just want to be familiar and stay not change with the times? But if you do want to change and if you want to upgrade your application and you don't have the expertise yourself to do work with Quarkus, we have a lot of partners, including Geniusee, who are very skilled, and you can get developers who can do that migration for you and greatly simplify the experience, and you don't have to worry about how to migrate and stuff like that.
In protection of Quarkus, you mentioned about AI chatbots. Quarkus has pretty good documentation. Spring too, I know, but if you want to, if you know how to integrate with something, for example, with the same 𝗁𝗃𝗲𝗃, it's pretty simple and fast to find correct page with documentation or Quarkus.io, and find manual where you can set up or everything as you wish. But I understand your point. I agree with you about experience.
Yeah, you're an expert. Yeah, you might be biased because you're so expert, so good at Quarkus. Yeah. All right.
All right. I think that concludes our Q&A. Any additional comments or wrap up, Andrii or Bhavye?
Yeah, go ahead if you have a point.
Yeah, just this QR code is pretty interesting. You can scan it. It takes you to Geniusee's page where they dive deeper into Quarkus and what benefits it has. So if you missed any of this webinar, you can get that information from the QR code as well. Right. Thank you. Thanks, Geniusee. Thanks, 𝗁𝗲𝗄, for moderating and taking care of chat. And thanks, Andrii and Geniusee, for inviting me on.
Thank you, Jim. Thank you, Bhavye. Thank you, 𝗁𝗲𝗄. See you.